I'm only going to do aldehydes today, okay? We have brand new bulb, nice and bright. What's that? Yeah, I know. It doesn't take very long, though, because Dr. Jekyll and aldehyde, which, by the way, when I said that, I'm not kidding you, two people in the last class, and it's not like it's a big class, had no idea, had never heard of Dr. Jekyll and Mr. Hyde.
Was one Allie?
Well, no, she wasn't here, but only because she wasn't here. But how about that? I mean, that is an amazing thing. I mean, there are certain, as you become older, you realize that half the stuff, half the analogies you use, half the references you use, go right over your guy's head. Right over your guy's head. You have no idea. Yeah. Anyway.
Wait, you have to do it.
Yeah, you're going to explain who this is?
I'm not telling you who it was, but they'll tell you, I'm sure. All right, aldehydes. How do we name them? All right, well, you probably have heard of one, right? But that's not how you've heard of formaldehyde. But that's not how you actually, again, that's the common naming system. So I'm going to show you how to name it by the UPAC system. First of all, you name the alkane and all that implies. That means you have to name it 2,2-dimethyl, 3-ethyl, 4-chloro, whatever it is. All right, you name the alkane. And remember I said alkane here, not alcohol. So it's not YL ending. All right, so I'll bet you'll be able to get this first one. Just by it's only a two-step procedure here, you add an AL suffix. I mean, we've done this before. This is exactly the same thing you would have done for an alcohol, all right? Same way you would have named an alcohol. You know how to name alcohols, right? You should know how to name aldehydes. The difference is going to be instead of an OL, you're going to have an AL. So you better write it nice. I better be able to tell the difference between an A and an O, okay? Let's try an example. We'll do the most famous one, the one that you already know, one that is formaldehyde. Oh, I want to use black.
Racist.
I know. All right, that would be the smallest aldehyde I could have, right? One carbon. With this carbonyl group on him and nothing else, what would I call this guy?
Methyl.
No. Again, it's not the methyl group. It's the whole alkane. And then think about how you would have named him if he had an OH on him. What would he have been for an alcohol? Methanol. How would you name him for an aldehyde? Methanal, exactly. See, this all makes sense. That's the nice part about this system. The reason you use a UPAC system, a very systematic way of naming these, is it's easy to teach. Problem is, you go to college and they don't use it. They end up using the common names for almost everything. So, for example, if you were to go to the stock room, you're not going to get methanol. You're going to get formaldehyde.
Can I pronounce it methanol?
You can pronounce it methanol if you wish.
All right.
All right, pronunciation, I can't really take off for that. All right, formaldehyde is methanal. By the way, notice the prefix form. You're seeing this in the common sense, common naming system all the time. You saw formic acid. We use it to make the one of our esters, the one that smelled like, who used formic acid? What group used formic acid in the ester lab?
Maybe.
You know,
what does it smell like?
It doesn't smell. I mean, it wasn't the fume, but anyway, you wouldn't have smelled it. That's not the one like the butyric acid that really stunk.
I don't think it was.
But either way,
Either
way, you would have made, like ethyl formate or something like that, or pentyl or amyl formate or whatever it was you made. Form means what? Formic acid was this acid. This is what formic acid was. Okay. What do you think form as a prefix in a common naming system probably means? One carbon. Okay. Formic acid is the stuff I told you. Formaldehyde. Stuff I told you. Formic acid comes from ants. Okay. Fire ants. All right. Another example of one would be this guy. Just so you have an idea. Do I need to number him? Not really. Okay. Aldehydes and carboxylic acids are assumed to be. They have to be. Not assumed to be. They have to be at the end of the carbon chain. So I really don't have to call this guy one what? Propanal or propanal, as Holden wants.
Actually, propanal is easier to say propanal.
Propanal. I don't. It does not have to have a 1, though. Okay, I don't have to have a 1 because if it's anal, it would be number 2 anyway. Just made that up. I probably shouldn't be in there. Anyway, propanal. All right, so propanol.
Are you recording yourself?
Yes, we are. Unfortunately. Now look at I erase this and tell you again, we have the test this week. It's definitely going to be this week. We're almost done. We have basically today, I'm going to finish up that one sheet, which is not much. I'll do an example and a couple of other problems. But by the end of the week, we're going to have the one half of the test, which is not going to take a full period. That's going to be these things all over the place. It's going to have a whole bunch of them to the side, and then at the top will be classify them as alkane, alkene, alkyne, alcohol, carboxylic acid, aldehyde, ester, whatever. Look at how similar these guys are. Look. What's that guy? Carboxylic acid, not to be confused with that guy. That should be an R. That should be an R there. OR.
OR.
What is that? What should that guy be? Ester. Remember the esters? I mean, we only did like 100 of them, okay?
What's an ester?
And here's this new one, which you're going to get tomorrow. That. Now, these all look similar. They all have this carbonyl group in them, all right? But they're all different. This guy's an aldehyde because the carbonyl group's at the end. This guy is called, we're going to learn tomorrow, a ketone, all right? This guy's an ester. That guy's a not keystone. Ketone.
It's keystone.
Keystone.
I always thought ketone would be a great name for like a band made up of chemists. The ketones. That'd be okay.
When do you see that? When do you see that?
Yeah, I don't really. I thought Band of Brothers was a better name, so that's why we use that one. But ketones would be a good one. We weren't all chemists either. All right. First way we can make an aldehyde. Okay. To make an aldehyde, you have to get Dr. Jekyll and get his serum, and then. You guys even know the story of Dr. Jekyll and Hyde?
No.
I know who they are. I just don't. I just read the story like 2 weeks ago.
Oh, really? You had to read it for high school?
Yeah.
Wow.
So
and who wrote it?
You had to read it for middle. That one guy.
That one guy. That one guy wrote it. He wrote a lot of things. The one guy.
How about after we're done, you explain it to us?
It's pretty. Actually, Dayton already. What do you think, Dayton?
They wouldn't comprehend it.
They wouldn't. You wouldn't get it. You have to be a senior.
Now you're calling us stupid.
Exactly.
Yeah, bullying. Stop. Okay. No. Dr. Jekyll. You all know the story of Dr. Jekyll and Mr. Hyde. It's a guy, a professor, who's trying to like isolate the good and the evil side from human beings, and he takes this potion, and eventually turns out it seems like it gets rid of his the evil part of him, but that comes out like he starts to change, and it comes out eventually unexpectedly. He can't even control it anymore, and he kills people and stuff, and eventually I guess he dies in the end, doesn't he? Yeah. But anyway, there's been a lot of movies made of it. It's like a classic. It's Halloween. Seriously? You've never heard of Dr. Jekyll and Mr. Hyde? That's pretty bad.
Do you do Halloween in your house?
We do. You're not coming.
No, I'm not.
No, it's supposed to rain on Halloween anyway.
Yeah.
So I don't think there's going to be as many people out.
Are you dressing up as a chemist?
I might.
Yeah, that'd be the easiest costume. You can just grab random stuff.
Okay, now you have this guy already on there. All right, and he looks like this. I'm going to do one example. It's the only one I'm really going to do an example in your notes for, because we're getting to the point now where I think this is what, Roman numeral 7, and each one had both preparation and reactions of, and each one had multiple ones of those. So you're talking about, we've probably done about 30 examples on the board, let alone the number you've done on your worksheets. You've done 3 worksheets, each with like 7 or 8 apiece. So I don't need to do an example of every one. Let's do an example of this one.
Chromochromate?
Yeah, pyridine chromochromate. Great name. This guy is a oxidizing agent. And if you notice what happens to him, all right, you're basically losing some hydrogens. The oxidizing agent is going to either get rid of hydrogens or add oxygens to it. Now let's do this reaction. And I'm going to use him to illustrate a point. Actually, a couple of points. Oh, and by the way, this came up in the other class. This 1 with a degree sign isn't like making a percent. All right, it's not 1 degree, it's not 1%. What does 1 with a degree sign mean? I told you this a couple of times already. It means a primary alcohol. And what does primary mean? Which is a primary carbon. Is this a primary carbon here?
No, it's only one thing attached.
Exactly, it's one with only one thing attached. This guy's a what kind of carbon? Tertiary. So if I had no H on that, it would be a tertiary OH, tertiary alcohol. If I had no H on this one, it would be what? What kind of an alcohol? Secondary. But because he's on the end, and he has to be on the end to make an aldehyde, because he's on the end, when I oxidize him, I will get this.
So that OH could be on any.
Absolutely not. He cannot be on any of these. He can be on the end
That's
carbons.
what I
Yeah,
meant.
he can be on the end carbons, but of course he'll give me a different name. Okay, let's do this. Oops, there's no H. There's nothing there. I'll erase that in a second.
Well, there is something.
There is an H there, yes. All right, and that's plus hydrogen too. Now, the nice part about this, like so many of these organic reactions, which we already see, like I said, about 30 or so, so many of these reactions, it's already balanced. All right. What happened was those two H's came out of there, went over there, and I got a double bonded O, a carbonyl group that showed up on the end of the chain. Now, where are your mistakes made? Well, one mistake is this. So many people do this. When they redraw it, I mean, if you look at your worksheet, I'll give it back to you. That's how they'll redraw it. They just don't redraw the methyl groups that I have on the other side. They just make the straight chain. I don't know why people do that. They've done it forever since I've been teaching. If I've got a methyl or an ethyl or something else over here, it's why I'm doing ones that have other things. I have to have them over here. I don't just lose it. That's number one. Number two is, and when you get these back, you're going to see a lot of people did this. Numbering this wrong or not numbering it at all. This guy is called what? 3-methyl. 3-methyl what? 1-butanol. And there you go. Here's several mistakes you can make. You can call this, people will do this, so listen carefully. They'll call this 2-methyl 1-butanol. Because they go from the shortest side this way to the shortest side that. You can't do that. You got to pick one. And the guy that takes precedence is going to be the OH. 2, they'll forget what bute means. So many people did this. Even easy ones like pent and prop. All right, they'll mix the guys up. Bute is 4. So just having the wrong number of carbons. All right, and finally, and the biggest one, the one I saw the most in the sheet I'm going to get back to in a minute, not putting a number at all. Just not putting a number next to it and forgetting the number completely. All right, now when you go over here, I have to name him the same thing. I got to call this guy 3-methyl. And I don't really need 1, but what would he be? Butanol, right? I don't really need a 1 here because to be an aldehyde, he has to be on the end carbon. All right, he's going to have to be a 1 there anyway. So 3-methyl butanol. Somebody was asking last period, well, would it make sense to just put a number next to everything anyway, just in case? I won't take off for it, but there are, and I've seen it. People come back to me with their notes from college all the time. I see their reports. I see their tests. And there are professors who absolutely would take off if you put an unnecessary number next to something. All right, just like in using this as an example before. Just like I've seen professors who, remember I taught you how to do electron or to write a compound like Al. You write the charge +3, chlorine. You write charge -1, and then you need AlCl3. And okay, I let you leave it like that, and they would absolutely take off points because you left the charges in there. That's the ionic formula. This is the actual formula. Or putting parentheses around things that don't need it. For example, if it was AlNO3, I need parentheses around that, right? But I told you back when I was teaching how to do this, I don't care if you leave them around anything, because remember, the big thing I was trying to get across was the whole polyatomic ion has a -1 charge. So if you had NaNO3, -1 +1, and you left like that, they'd take off points. Because it should be written like this, NaNO3. You don't need the parentheses around it. Okay? I know that sounds like it's being real picky, and it is. But eventually, that's the problem. College professors will eventually get to the point where they want to weed out people who aren't meticulous about stuff. They probably feel that they're doing the world a great service. And maybe in a sense they are. I mean, maybe at some point or another you have to be meticulous about things. If you're going to be a doctor, you can't just cut corners all the time. If you're going to be a pharmacist and you screw up, you're going to kill somebody who are given the wrong medicine. So I understand that, but we're in high school, and so I let you go with a few things. So to go back to my original statement here, some people want to just put down the numbers next to everything anyway, even if you don't need it. Make sure you understand, if you do that for me, I won't take off for it if there's an unnecessary number there, but if you do it for somebody else, they probably will, just so you know. All right, let's go to the reactions of aldehydes. All right. If I'm going to make I'm going to take an aldehyde and make something else, I can reduce them to an alcohol. Now, why do I not give you an example of this guy? What is he basically the same thing as? Only reversed. Yeah, it's the exact same thing. Here you took a primary alcohol and you turned him into an aldehyde. Here you took an aldehyde and you turned him into a primary alcohol. So it's just the reverse of the first one. I don't need to do an example. I could do the same two guys there, and it wouldn't make, for much use to do that. The next one, oh, by the way, before I get rid of this page, notice again, like most organic compounds, they don't need to be balanced because they already are balanced. If you just, obviously I'm not going to add all the H's, but if you take out 1, 2, 3 H's over here, right, and we have the same number over on the other side, all right, we have the same, we didn't lose or gain any.
How come you didn't want to be a college professor, Mr. Allen?
Who said I didn't want to be?
You wanted to be?
No. I mean, obviously it'd be nice to be a college professor, but you kind of give those, it's like, I'm the dream squasher, right, so,
Yeah.
It's like anything else. I mean, you watch that video today, you could be anything you want to be. Not really. You can't be anything you want to be. You have to be within reason. All right? You have to, and you make compromises, you make choices, you decide what you want to be. To be a college professor in sciences would take after you graduate with your degree. It's not like a lot of other ones. I mean, I went to college, after Scranton, went 1 year to Boulder, just 1 year. And I realized there are people in that program who were 7 years out of college who still didn't have their PhD. They were grad students for 7 years. Now, that's okay for some people who like that life. If you like to just, kind of kick back, hang out at the lab, do stuff for 7 years, not really care about when you get your life going, that's okay for some people. Some people are fine at starting their lives at 30. But I didn't want to do that. I did not want to. I was so sick of so sick of school by the time I got to college that out of college into grad school. I didn't want to spend 7 more years in college, which I'm not kidding you. That was like about the average time to get your PhD for a science person. It's going to be between 5 to 7 years average. I know. And that's after your 4 years of college. Now, that's not the case if you want to get your PhD in English, you want to get your PhD in a lot of other places. It's not that long. But in science, you have to do experiments. You have to do research. Some years, one person was working with frogs. And 1 year, it was this dry year, and the frogs they didn't get enough samples to even do it. So their whole year was wasted, because the frogs didn't come out. There was just weren't enough frogs. It was a bad year. And so it's like, who wants to? I didn't want to do that. I mean, that's okay for some people, but it wasn't for me.
Where'd you go? University of Colorado?
For 1 year, yeah. Boulder, Colorado.
Is there a big boulder?
It was a big boulder right there. That's why they call it Boulder. It's actually built on a boulder. No, it's not.
From bottom college.
And there's a slippery rock. It's slippery rock. Where you start that?
I can't. I have to go to the bathroom, Mr. Allen.
Yeah.
Should have become a smart board technique.
I know. How bad? This guy knows. I have to know how to talk to this thing. All right. He gets me back though. He does. All right. Now this guy right here, I'm not going to do an example of either. You can see it's pretty easy. What obviously happens here in an oxidation reaction, the potassium permanganate, we've seen that's that purple stuff. It was very impressive how dark purple it was, and we lit it on. We actually caught glycerin on fire with it. You add an extra oxygen on here. This is one of those, and it's written in your thing. I wrote NBR. Okay. Now there aren't many like that. There's about 3, I think, throughout this whole unit of probably I said maybe 30 reactions. There's 3 that I wrote this down next to it, where the actual reaction is not balanced, but you're going to have to. You don't have to balance it. You don't have to balance it. All right. There's only 3 examples of that. There's many others where they come out balanced anyway. But this is a case where I'm not going to ask you to balance it. It has to do with an oxidation reaction from the potassium permanganate, and I'm not going to ask you to actually balance the reaction. We have done potassium permanganates where we did balance them, including that glycerin one when we did redox reactions. But I don't want to get into that right now. Okay. We're looking at the big picture here.
Hopefully that's no
Okay, is that the last one on here?
Promo required.
All right, good.
No, bro.